a confidence interval for the population mean for a population that is normally distributed and where the population standard deviation is known. These are the weights in kilograms for luggage belonging to 7 airline passengers, and we can assume that this data is a random sample from the population, and the population is normally distributed with an unknown mean, which we're going to estimate using the confidence interval, and where the population standard deviation is known, and it's 10 kilograms. We're going to work out a 90% confidence interval for the population mean. This is the formula that needs to be memorized. The formula comes from a rearrangement of this formula, which is on page 12 in the AQA formula book, and it's Z is equal to this, and you can rearrange this to make the population mean here the subject, and by doing so you end up with this formula. The standard deviation is 10, and it's given, and this is sigma. It represents the population standard deviation and not the sample standard deviation. The sample size is 7, so n is equal to 7. The sample mean is 44.29 kilograms. For a 90% confidence interval, so 90% goes in the center, 5% in each tail, we look up 95%, so that's the cumulative probability to the left of this line, so that's the 90 plus the 5%, from table 4, table 4, 0.95, the Z value is 1.6449. So we have plus 1.6449 and minus 1.6449. So the lower limit of the confidence interval, so using the minus first in the calculation, is 38.1 kilograms. And the upper limit, using the plus, is 50.5 kilograms. The true population mean is a single value, and we're 90% sure that the true population mean lies between 38.1 kilograms and 50.5 kilograms. So there's a 10% chance that the true population mean is outside this interval, either below or above. To make comments on the whole process, it would be useful to comment on the actual interval here and to comment on the individual values here in the sample.